There are various allotropes of carbon which we will discuss in this video, but first, let's recap the definition of allotrope. Allotropes are different forms of the same element. They share similar chemical properties but can have very different physical properties. The first two we will be looking at are the ones we have learned in GCSE. The first one is graphite. It consists of carbons arranged hexagonally. The diagram shows that the atoms are bonded two-dimensionally because the carbons only form 2 to 3 covalent bonds each. The extra electron in the atoms that occupies p orbitals overlap each other sideways, forming a cloud of delocalized electrons below and above the layer of carbon atoms. These clouds can then join up, forming an extended ring of delocalized electrons. Next is diamond, which are carbons bonded tetrahedrally. As the bonds suggest, the structure of the diamond is three-dimensional. The regular arrangement of carbon atoms gives it a crystalline structure. The next type of allotrope we will look at are fullerenes. They are carbons bonded in rings, which forms hollow spheres or tubes. With one of their dimensions between 0.1 and 100 nanometers, they are also a kind of nanoparticle. Buckminsterfullerene is the first type of fullerene discovered. It has a molecular formula of C60 and the shape of a football. It has carbon atoms located in corners of 20 hexagons and 12 pentagons. Buckminsterfullerene, having a simple molecular structure, has a very different physical property compared to the first two giant molecules. It has a relatively low sublimation point of 600 degrees. In contrast, graphite has a sublimation point of around 3,700 degrees. It is relatively soft and also poor at conducting electricity. It is only slightly soluble in carbon disulfide or methylbenzene, and it is relatively more reactive than graphite and diamond due to the high electron density in parts of the molecule. Because Buckminsterfullerene is hollow internally, it can trap small molecules, and due to this property, it can be used to deliver drugs to specific parts of the body. The next fullerene we are looking at are nanotubes. They are fullerenes of hexagonally arranged carbons with ends of its cylindrical structure closed. Its properties include high electrical conductivity along the long axes due to having delocalized electrons, high tensile strength. To be precise, it can be up to 100 times more stronger than steel, and high melting point, which is around 3,600 degrees. Nanotubes are very useful. Here are some examples where nanotubes are applied. Nanotubes are used in forming metal complexes, making the metal stronger. They are also used as small wires in the mini circuits and electrodes in small batteries. They are incorporated into clothing and sport equipments to make them stronger. And lastly, they are used in some cancer treatments. This is all for this video. Thank you for watching and subscribe for more A-Level Chemistry videos.